Good morning. We will start with the chapter Motion, numericals on this chapter. Hope you remember we had done motion chapter in session 5. So session 5 was still theory, what we had understood about the chapter. Session 6 will be the numericals based on this chapter. How we will go about this is, there are even in-text questions what I usually tell, that is questions in between the textbooks which are given in blue or pink color. Then we have exercise questions. First we will start with in-text questions. Then after we complete all the in-text numerical questions, we will solve all the worked example questions given in the textbook, and after that we will solve the exercise questions. So as and when we go, I also will just tell you what page number it is, because it is easy for you to look into the page and even make a note. Please copy the question correctly and then start solving it. So page number 100, the first numerical is, see, numerical I will write accordingly the numbers. So the numericals will not go here 1, 2, 3, 4. Why? Because the numericals are given in between the question answers. So the first one is the question answer, second is the numerical, third might be the question answer. So make a note what numbers are right, follow the same numbers with the correct question. A farmer moves along. Before we write this, children, I think I need to just recapitulate about the formulas what we had done in this chapter. I think that is must and should. So the basic one, speed is equal to distance by time. Speed is given by distance travelled by time taken. Then apart from that we had done equations of motion. If you remember, we had derived them graphically. So equations of motion. So V is equal to U plus AT. This is the first one. It can also be written as A is equal to V minus U by T. Right? Second one. So we have second one as V square minus U square, or we can also write this as in the form of, I'll just give you, because let me write it accordingly how it is given in the book. 2AS is equal to V square minus U square, also written as V square is equal to U square plus 2AS. Anyhow you can write this or you can remember. Third one, S is equal to UT plus half AT square. Right? So with these formulas, let us just understand what are these, what is S, what is distance, what is time, and what is the SI unit. So where I will first write where V is equal to final, or first we'll start with U is equal to initial velocity along with that I will also write the SI unit, meters per second. V is equal to final velocity, meters per second. Speed is not given by S, speed is speed only. I will just write here where speed was given by also meters per second. Next what we have, A is equal to acceleration, which is nothing but meters per second square. Then we have T is equal to time, that is in terms of seconds. Then we have S is equal to distance, sometimes also displacement they give depending on the question with direction or whatever they mention, given in terms of meter. Yeah, we covered it. We covered speed, we covered distance, we covered time, we covered V, we covered U, and we covered T. So our numericals are going to be based on this. Now apart from that, I have also taught you one phenomena, that this is a circular, the body is moving in a circular direction. What is displacement? What is distance traveled? Yes, we have even one or two numericals based on this also. So what I want you all to do is give the heading as motion, then numericals. Then you can just write as heading as a formula and just make a note of these formulas quickly along with these SI units or what they actually relate. We'll quickly start with the numericals given in the book now. So, the first one, that is second one, page number 100. A farmer moves along the boundary of a square field of side 10 meter. So, this is a square field of side 10 meter. Right? C, D. So, this is how the farmer is moving along the boundary of a square field. Okay. So, the farmer moves along the boundary of a square field of side 10 meter in 40 seconds. That means he can move in this field around the boundary in that is 10 meter what we have as a side in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from its initial position? Magnitude of displacement. Displacement is the shortest distance between the initial and final position of the body. So, first of all, let us first write here now, given side of the square field is equal to 10 meter. So, farmer moves along the boundary. What do you mean by boundary? It's nothing but perimeter. The farmer moves along the boundary in 40 seconds. That is, perimeter is equal to 4 into S. So, that will be 4 into 10. So, perimeter is equal to 40 meter. This implies he moves 40 meter in 40 seconds. Keep this as it is. This is the actual thing. That means a farmer is moving 40 meters in 40 seconds. Next. What is the next part? What will be the magnitude of the farmer at the end of 2 minutes 20 seconds? So, if he is moving 40 meter in 40 seconds, then we will not take a displacement here quickly. We will just write here in 2 minutes 20 seconds. That is 2 minutes 20 seconds. We have to whole convert in terms of seconds. Now, children, 1 minute is 60 seconds. 2 minutes is 2 into 60 plus 20 seconds, which is nothing but 140 seconds. So, in 140 seconds, what is the distance or how much he moves? What we have to first find out. So, let us first find out. He moves 40 meter in 40 seconds. Therefore, in 140 seconds, the distance moved is. So, what will you do here? We have to just calculate here. This is he moves 40 meter in 40 seconds. So 140 seconds, if you see, it is a question mark. 140 into 40, by 40. Simple calculations. You get answer in 140 seconds. He moves 140 meter. Keep this as it is. Actually, what steps I'm following, children, because actually the sum is only done in 2-3 steps. I'm following all the steps just to make you understand actually what each procedure is here. Right? Now, the thing is, to find the displacement, first of all, we should know how many rounds he will take. Now, see here, to move that 40 meter, to move this 40 meter, how many rounds the farmer is taking? The farmer is taking only 1 round. To move 140 meter, how many rounds the farmer has to take? That we have to calculate. To move 40 meter, farmer takes 1 round. Therefore, for 140 meter, 140 by 40, cancel. So this is 4 3s are 12, 4 5s are 3.5 round. Right? Now let's just calculate number of rounds here with this respect. How the farmer has to travel? He has to start from here and he has to end. Okay? So he'll go like this way, and he will complete it. That's called as a perimeter. 1 round. So let's start calculating 1 round. I'll start here. I'll go here, this way, and come. 1 round is over. Second round. Again I'll start. I'll move to B, C, D. So perimeter when I discover. Second round is over. Third round is also over. Okay. Now 3.5, 3.5 rounds he takes. That means the farmer takes 3.5 rounds. He will start here, he will go here, he will stop here because that is a point for 3.5 rounds. 1 round, 2 round, 3 round and half round he will take. So because in 2 minutes 20 seconds, that is total in 140 seconds, the farmer will take 3.5 rounds. What is the displacement? What is the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds? That it is nothing but 3.5 rounds. What is the displacement? Displacement they have asked you. Displacement is the shortest distance between the initial and final. So this is my initial position and this is my final position. Okay. So now AC distance I have to find, which is nothing but a diagonal. So let's start. I think we had measured it as a square. What is the measure of? Actually, there is a formula to find directly. You should know what is the square of the diagonal measurement. It is nothing but root 2 into side. That's the known part. Direct answer also you can apply. What is the measure of the diagonal of a square? Anytime the question comes, it is root 2 into side. How it comes? Let us see. So we will write here is magnitude of displacement. Magnitude of displacement at the end of 140 seconds is length of AC. So AC square is equal to AB square plus BC square. Reason Pythagoras theorem. Ten square plus 10 square. So AB is 10. Square of this is 10 and square of this is 10. 100 plus 100. AC square. AC is equal to, AC square is equal to 200. AC is equal to root of 200. Now we know how to split this. 100 into 2. AC is nothing but 10 root 2. I'm sorry, I went wrong. It is not root 2 side. It is side root 2. Yeah, I just completely missed that part. So diagonal of a square is always nothing but the answer will come in form of side root 2 or root 2 into side. That is how we write. Side is nothing but 10 here and root 2. So AC is equal to 10 root 2 meter centimeter. What they have given? Meter. If you want, root 2 answer can be taken as 1.1 and 1.1 for that you can multiply with 10 and write, or you can also keep the answer as 10 root 2 meter. Is this very clear? Now this is how you solve it. I have actually elaborated. Now usually what I have seen sometimes in school or sometimes directly doing this 140 seconds, I don't know how you calculate that into 3.5 rounds, and in 2-3 steps you arrive at the answer. I made a point of just elaborating point wise so that whenever, even tomorrow when you read this, you will understand how did you get 140, how did you get 140 meter, why it is 3.5 rounds, what is exactly this displacement. That is how I have elaborated these questions with all simple steps and make you understand clearly. So answer is 10 root 2 meter. Give the conclusion. Anyhow, whatever we have written, therefore the magnitude of displacement at the end of 2 minutes 20 seconds from the initial position is 10 root 2 meter. So we'll go with the next one now. A similar type of sum is also there in the exercise. When we solve, you will get an idea. Okay, now the next sum, what we have to do here is, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship? I am just writing the question number. These are all, again I am repeating, in text questions which are all given in blue or pink color in your textbook. So speed is given as speed of the spaceship, the speed of light, that is, we should know 3 into 10 raised to 8 meters per second. This is the standard speed of light. Meters per second can also be written like this, or ms minus 1. You all should know this, children, in exponential form. Then what they have given? Time. What is time mentioned? Time is mentioned as 5 minutes. Now, when the question is in terms of meters per second, time also should be in terms of second. Convert it. 5 into 60. 300 seconds. In terms of minutes and seconds. What I have asked? What is the distance? Speed, distance is equal to question mark. Speed is equal to distance by time. This is simple and direct one. So speed is 3 into 10 raised to 8 is equal to distance. Do not write distance as shortcut with d as time as t and speed as s. Write speed, distance and time as it is. Time is nothing but 300. Distance is equal to 3 into 10 raised to 8 into 300. So 3 3s are 900 into 10 raised to 8 meter. You can also write this as 9 into 10 raised to 8 plus 2, which is this 2 I have taken here. 9 into 10 raised to 10 meter. Very clear? We'll go with the next one. Page number 103, second one. We'll be only solving few sums today. Practice these sums, then more and more we can solve by the next session. So don't get confused with the session 6. Remaining sessions were the theory sessions. So the question numbers again, I'll just put according to the textbook question numbers. You also write accordingly. Page number 103, second one. A bus decreases in speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Learn to understand what is given. acceleration we have to find. A bus decreases its speed from 80 km per hour to 60 km per hour. The bus is going with some velocity, which is 80 km per hour, and it reduces to 60 km per hour. So initial velocity of the bus is 80 km, final velocity of the bus is 60. Now how do I come to know what is initial and what is final? Always, the bus is moving. When the bus is moving, that means it is with initial velocity moving. It increases the speed, decreases the speed, later something, that is final. An object at rest, initial velocity, then moves with some velocity, final velocity. You will understand as and when we proceed with the sums. So the bus decreases its speed, u is equal to 80 km per hour, and I am leaving some space, I will tell you why, is equal to 60 km per hour. Find the acceleration of the bus in time t is equal to 5 seconds. Everything is in terms of, this is given in terms of seconds. U and V is in terms of kilometer per hour. It is not feasible to convert 5 seconds in terms of hour, right? Rather, we have to break down this U and V in terms of meters per second. Remember, there is one conversion. I will tell you what conversion with a direct step, but initially I will show you with the steps what to do. Kilometer per hour, children. That's why I have left space here so that we can write. So, kilometer per hour. 1 kilometer is equal to 1000 meter, and 1 hour is equal to 3600 seconds. How did I come to 3600 seconds? This only once I'll show you. I know you will be knowing this, but this is for some who even doesn't know why this is 3600 seconds. Let me come to this. 1 minute is equal to 60 seconds. Okay, so 60 minutes, which is nothing but 1 hour, is equal to how many seconds? So 60 minutes is equal to 60 into 60, that is nothing but 6 6 are 36, 0 seconds. Minutes is nothing but in terms of hours. So is this conversion very well known? Okay. Kilometer per hour, so which is nothing but 1000 divided by 3600. 2 zeros, 2 zeros. 2 5s are 2 18s are. Meter per second. So always remember, whenever you have to convert a kilometer per hour into meters per second, you may not do all these things. This is one time for your understanding. Directly you can write this as 80 into 5 by 18. Remember this 5 by 18. Nobody will give you wrong. It's a known formula what you can say. Directly kilometer per hour can be converted to meters per second just by multiplying by 5 by 18. And this is not vice versa, children. Meters per second, if you want to convert to kilometer per hour, don't multiply by 18 by 5. It will not work out. This is only to convert kilometer per hour to meters per second. Remember, to meters per second conversion, right? 5 by 18. We have done this, and I prefer keeping the all these u, v or whatever in terms of fractions rather in decimal. Why? Because at the end the calculation becomes very simple when you have this in fraction. Please try following these things. What usually I have seen children is they divide, keep in decimal, final answer you will struggle to divide if there are many decimals. Try to keep that in fraction. So here if I check is 2 9s are and 2 4s are. So 40 into 5, 200 by 9 meters per second. Keep this as it is. Okay. This will be 60 into 5 by 18. 2 9s are, 2 3s are, 5 3s are 50 by 9. I know this will get divided by 3, but keep that. It will be easy for us later, calculation wise. Again, 3 3s are you don't know. LCM it will be easy. Kept it as it is, 5 seconds. Acceleration I have to find. I know the direct formula. A is equal to, see there are three formulas still, you have a confusion. Remember in congruency criteria, we listed down three criteria there. Then we selected which criteria. Always whenever you have such type of a sum, write down the three formulas what you have. A is equal to V minus U by T. Then V square is equal to U square plus 2AS. S is equal to UT plus half AT square. Check which formula is suitable for what. Always one unknown can be found out. So here I have to find out T. Here I have to find out A. V is given, U is given, T is given. That means first formula is applicable. Follow these techniques and rules. You will never go wrong in these numericals. So A is equal to V minus U by T. Understood why I kept that in 9 only here? It will be simple. You will set 3 3s are 3 5s are. Again taking LCM. So V is how much? 150. Substitute properly. Minus U is how much? 200 by 9. Whole divided by 5. So 150 minus 200 is minus 50. Minus I am getting. Is it correct? Of course. Read the question. The bus decreases its velocity. It was more, it came to less. That means definitely the bus is going to have a negative acceleration, which is retardation. Minus 50 by 9 into 1 by 5. Reciprocal of this. 5 ones are 5 tens are. I do it here. A is equal to minus 10 by 9. Divide this. A is equal to minus 1.11. This will go on meters per second square. Now in textbook, in other books they have given 1.112 or 1.12. Approximately they have taken. Always in decimals when you get children, 1 or 2 points here and there is always correct. So is this correct? What we have got? This is how we have to find it. Major thing you should know. What I have done here, these calculations, how to come about this is very, very important. Right? We'll quickly move to the next sum. Now next sum, anyway, if I have kilometers per hour, I will again not sit and do this. I will directly make that as 5 into 5 by 18. Remember that 5 by 18 always. And nobody will ask you how did you divide and why did you do that. It's a correct rule and the correct formula what you can apply. I'll always keep off 3 formulas here. A is equal to V minus U by T. V square is equal to U square plus 2AS. S is equal to UT plus half AT square. Next one, on the same page what you have, a train starting from railway station, first we'll read the question, and moving with a uniform acceleration attains a speed of or velocity 40 km per hour in 10 minutes. Find its acceleration. Read. A train starting from railway station. A train is starting from railway station means it attains a velocity later. You start your vehicle and you raise the acceleration and you increase the velocity, right? That means you started the vehicle which was at rest. That is understood. So U is equal to 0. This is how we analyze and understand the sum. A train starting from railway station means the train was at rest. Moving with a uniform acceleration attains the speed. V is equal to 40 km per hour. That is equal to 40 into 5 by 18. 2 9s are 2 2s are. So this is 200. Sorry, 5 to not 200. 100 by 9. Keep this as it is. And 10 minutes. Time is equal to 10 minutes. So let's convert the time in terms of seconds. 10 into 60. 600 seconds. What we have to find? Find the acceleration. Again the same. V, U, T. A is to be found out. A is equal to V minus U by T. So V is how much? 100 by 9. minus 0 divided by 600. So this is 100 by 9 into 1 by 600, 0, 0. So this is 1 by 9 6 are 54, sorry 54 meters per second square. I still want some, you can keep it here as it is, right? Or see, again it depends on your teacher. Sometimes your school teacher will tell, no, you can't keep this in fraction, you have to bring down in this in decimal. You have to bring it down in decimal. So always talk to your teachers and find out, can we keep the final answer like this, or we have to keep it. Nothing should do, both are equally right. If you want to divide 54, first I'll take 0, I can take 1. So ones, I took one's decimal, so 1 0, but still I am not able to divide, so that was 1 more 0, 1 more 54, ones are 54. So like this, when I go on taking at least for 2 decimal, 0.0185 what it comes. So it is 0.0185 meters per second square is the answer. This is how you have to do it, right? So give the conclusion. Hence the train, the acceleration of the train is 1 by 54 meters per second square or 0.0185 meters per second square. We'll quickly move to the next one. Page number 109. A bus starting from rest, directly it is mentioned, question number 1. So bus starting from rest moves with a uniform acceleration which is given as 0.1 meters per second square for 2 minutes. So 2 into 60, 120 seconds. Find the speed acquired. Find the speed, that is final velocity acquired, and find the distance traveled. Here distance traveled is x with respect to this. Now first of all, to find the first, I think the first formula is applicable. Using first formula, can I find v here? Is it possible? Because if I apply second formula, children, acceleration is known, v, yeah, I can also, v is not known, s is not known. I can't use second formula. 2 unknowns I can't find. This and this I cannot find. This of course, s I can use, u is there, t is there, right? Anything. I can also use this formula because I know u, I know t. Using that I can find s directly and then v. It's up to you. See the probability where you can, what you can apply to find. Let me go with the first one. You can also use this formula directly to find s first here, because you know u, it is 0. You know t, it is 120. Using that you can find s. After finding s, you can directly apply this formula and find v. Up to you. I will choose the first one. So a is equal to v minus u by t. So a is 0.1. V is, we have to find minus 0 divided by 120. So v is equal to 120 into 0.1 is 12 meters per second. Okay, cross multiply with this. Next, what we have to find? We have to find s. Shall we take up that formula or this formula? Anything. So we'll take second one and see now. Or we'll take the third one. V square and u square what we have. We'll take third one. S is equal to ut plus half at square. U is 0. Becomes very easy because half the terms are not there. 0 into 120 plus half into a is 0.1 into t is 120 into 120. Why? Because it is 80 square. So this is 0 plus 2, or what we can do is 12 12 is 144. 0 0 after 0.1 I will write like this, divided by 2. Is this very clear? 12 12s are 144. 2 zeros will come into 0.1, this decimal, divided by 2. Anyways, plus 0 it is. So 2 7s are 14, 2 2s are 4, 0. S is equal to 720 meter. Right? Make your calculations as simple as possible so that your multiplication division becomes very easy. The similar part, I think the next page number 110, the second one we will see here now. Of 90 km per hour. The train is traveling with the speed, children. So this is second one. If it is traveling with the speed, that is u. 90 km per hour. So how do you write? 90 into 5 by 18. So 2 9s are 18. What we can say here is 2 45s are 9 1s are 9 5s are 25 meters per second. Fine. Next, a train traveling at the speed of this, brakes are applied so as to form a uniform acceleration. Whenever brakes are applied, acceleration they have given, brakes are applied means of course velocity will become less only. Directly they have given acceleration is minus. Use same thing how they have given. Meters per second square. Find how far the train will go before it is brought to rest. How far the train will go before the train is brought to rest is 0. If the train is here, which is moving at this distance, and suddenly here the brakes are applied. It is not your two-wheeler. You apply brakes and the train will stop. Even your sometimes two-wheelers will skip when sudden brakes are applied, right? So when you apply brakes, usually I think it happens in the train. When you apply the brake, it takes for some distance to go and stop for a while. So if the brakes are applied at this point, it will move to some distance and then the P will become 0. Calculate that as they have asked to find here. So find how far the train will go before it is brought to rest. U is known, A is known, S is to be found out, V is known. I think this is the right formula to find. Second one. Let's apply because continuous time is not required only there. Directly apply. V square is equal to U square plus 2AS. V is 0. U is 25 square plus 2 into minus 0.5 into S. So 0 is equal to 625 minus, be very careful, minus into plus is minus. 2 5s is 10. So it is minus 1S. Shift this side. 1S is equal to 625. So distance is equal to 625 meter. Distance should always be in positive. Distance can't come in negative. Okay. So I think we will stop with today's session because I can't load you all with so many sums on the day 1 itself. So slowly, gradually we will start moving to more and more sums. I want you all to first understand, practice these sums. What I have found out is you usually see, if I give you everything, I know you can apply this directly. I know everybody can do it. It's very simple. Only 3 formulas you have and you know how to apply it. But the thing is, you should know how to write this. This is main important, and that comes only by practice, by reading the sum slowly, understanding what is given by part. How in mathematics, linear equations or quadratic equation kind of verbal sums, how we read those verbal sums, a small part, we write it down. Similarly here, understand the given question. The given is more important. Once you write the correct given here, applying formula and writing is very simple. So with this, we will end with today's session. Please practice the sums very clearly.